CE4CON, funded under the KYKLOS project, proposes an innovative, user-centric solution to promote circular economy principles in the construction industry. The platform aims to reduce the energy and material consumption in the construction industry by promoting sustainable practices. These include a better design for making modular and easily disassembled components, where manufacturers prioritize separating materials, reducing complexity, and minimizing energy used during manufacturing. But also, pre-demolition material auditing and waste management planning. An accurate and selective disassembly operations preparing materials for reutilization and recycling, and enhancing traceability, quality assessment, and certification of construction and demolition waste streams. The construction sector lacks a comprehensive life cycle perspective when implementing building components and systems, with consequential resource and energy loss in end-of-life scenarios. Reducing waste and promote circularity can bring significant benefits to developing economies in construction, and lead to a boost in their competitiveness towards emerging markets. Also, the project benefits from the KYKLOS tools, which provide a mature and flexible ecosystem that significantly speeds up the process. The solution offers a wide range of services, integrated with a common backend. A cloud-based platform for circularity data management collects available environmental and circularity data about supplier options and store data about their life cycle. It allows users, such as designers, managers, quality departments, and procurement teams, to manage and obtain pertinent information, thanks to a user-friendly solution. Also, it facilitates the entire value chain by matching demand for new materials with the availability of recycled products. The designer support tool is conceived for the detailed design phase in the early stages of the product life cycle. The designers can identify suppliers for each building envelope component with the lowest environmental impact and better circularity characteristics. Finally, an augmented reality snag list and dismantling support tool gives a twofold contribution. The snag listing function allows the user to take note of damages in the facade so they can be more easily catalogued and remain visible during dismantling in the future. The dismantling section provides real-time information on the availability and recyclability of building materials and components. The CE4CON solution is fully integrated with the KYKLOS services. The KYKLOS LCA simulation engine enables CE4CON to assess the environmental impact of different design and material choices during the design phase regardless of the amount of environmental information available from suppliers. CE4CON has been able to collect primary data related only to global warming potential, and sometimes incompletely. Instead, thanks to KYKLOS LCA, it evaluates aspects such as energy consumption, resource depletion, and waste generation, allowing for informed decisions based on environmental factors. This ensures that CE4CON's circular design principles contribute to a sustainable built environment. The KYKLOS PLM module supports CE4CON by facilitating data exchange and storage using international standards. It enables manufacturers to integrate independently designed products and components and serves as a central product data repository, and allows external legacy systems to connect. The KYKLOS blockchain auditing platform was examined to store designs immutably. The KYKLOS auditing system offers API interaction with the platform, and in the future it could be used as a view-only option for other auditors to confirm the design. The cloud-based platform was used to create a sufficient number of circular entities to provide different options for various prefabricated modules for curtain walls components within the selected demo cases. 38 circular entities have been created, reflecting the diversity of data required for different components and use cases. Technical data constitute the attributes of each circular entity. The list can be customized for the specific entity to include other relevant information. By accessing the Designer Interface tool, the designers can identify suppliers for each building envelope component with the lowest environmental impact and better circularity characteristics. Firstly, when accessed, the interface prompts the designer to input an ID code of the prefabricated modules for curtain wall. By entering this, the backend connects to the KYKLOS 4.0 PLM service to load and show all project data linked to the particular module code. The interface then allows designers to compose a list of materials, starting from the one available in the Reuse Cloud platform showed previously. At the beginning of the design stage, no circular entity has yet been selected as an option for the various facade module components. By clicking on each empty entry, the designer is taken to another section of the interface. Here, the designer can select the materials in the Material Type and Circular Entity Type fields and enter keys for searching for possible circular entities in reuse. By selecting these two necessary data sources from the PLM service and reuse, the backend has enough data to communicate and make an API request to the KYKLOS LCA to obtain the necessary impact assessment information. Doing that, it populates the Module Life Impact Assessment fields. At this point, the designer has a complete overview of all the material data, process data, impact assessment data, and circular data available to them to make a suitable choice. They can confirm or modify their design until they are satisfied with the choices that have been made, after which they click on the Save option. Moving forward, the designer clicks on the following Material or Process ID field and proceeds to follow the steps again until the list is a complete representation of the facade design. When the design stage is completed, all the information the designer wants to know to finalize the design is available to them in a unified interface, and the module design is complete. The Augmented Reality Snag List and Dismantling Support tool allows examining the mounted prefabricated modules for curtain walls to obtain or update a snag list, as well as retrieving dismantling and pre-treatment information to facilitate the disassembly and the update of end-of-life information of the module. On the Rialto homepage, the user is asked to enter the unique ID code of the module to be assessed. The app also supports barcode or QR code scans. In the snag list section of the app, the user can see and edit existing audits, as well as create new ones, by adding an audit name and an auditor name. The same holds for defects. Once an audit has been activated, it can be associated with one or multiple defects. The defect can be placed in the 3D space using augmented reality or just by providing a text description, written or converted from voice. Augmented reality allows to see the defect to other people and even in subsequent inspections, thanks to the integration with the backend. In the dismantling section, the user can download the module's technical drawings to guide and ease the dismantling of the module. Then, through the CES list, it is possible to see the list of components. For each of them, Rialto allows the user to see the relevant properties, notify the dismantling by setting the corresponding status, dismantled, not dismantled, unknown, and provide a description of the dismantling process. Finally, textual on-site disposal describes the possible end-of-life scenario of the component. In conclusion, the CE4CON solution presents a robust framework for promoting circular economy practices in the construction sector. Also, thanks to the integration with the KYKLOS tools, the achievements of the project highlight its potential to reshape traditional construction processes. Finally, the platform was validated on a real use case demo tester thanks to the contribution of the end user.